All right, there's our objective. I can multiply and divide with negative and positive fractions. So before, when we did this, I think in Module 2, it was just strictly with positive fractions. Now we're going to add negative fractions into it, into this multiplying and dividing, operating with fractions. But the good news is if you have your multiplication and division rules down for negatives, it's a cinch, because when we do these problems, it's the first thing we're going to do is just decide if the answer is positive or negative, and then ignore all negatives. Like I was saying, the first thing that I want to decide is my answer going to be positive or negative? Because if we can determine that, then we can ignore all the negatives completely, and then we operate as though there were no negatives present at all. So in multiplication and division, this is just for multiplication and division. We don't use this method for adding and subtracting, only for multiplication and division. We will determine if the answer is positive or negative, and then we will do the operation, just like I've been talking about. Determine if the answer is a positive or negative. All you got to do is look and see how many negatives are there. Now, this is just the way that I do it. But the truth is that a lot of teachers do this a little differently as well. So odd, if you have an odd number of negatives, then your answer will also be a negative. If you have an even number of negatives, then your answer will be a positive. Oh, if I could spell positive, there we go. That's not a great E, but I'll deal with it. Now that may not be what you were told in your classes, right? So let's add something else to this. So how many negatives are there, odd or even? The even one, just the even one. If you have an even number, they may have said something like 2 negatives make a positive, okay? So if you start pairing negatives in groups of 2, then you end up with positives out of those, which is why in the past, when we saw something like this, like a negative of negative 4, something like this, these two right here, 2 negatives that I've highlighted in green, end up being a positive, and then we pretty much get, I missed one of the parentheses, but we get to pretty much ignore them all together, and so the final answer itself would have been negative 4. So if I were to rewrite this as it was or should have been, the final answer here is just a regular negative 4. But again, it's because of these 2 negatives. Now that's the same, and we say this works this way because this is all multiplication.
If it's just one.
So this one, it's, let's say you got -1 and -1. It's kind of like we're saying take -1 and multiply it by -1 right here. So if you have, let's take this a little bit further. Now I'm not going to put numbers in here, okay? So I'm going to say let's look at some fractions, and we're going to multiply these because we just want to do the simplest thing here. In fact, let's do 5 different fractions. Now again, we're not going to put numbers in here because I don't really care about the numbers. So if I had these 5 fractions, and let's say this one, maybe it showed this numerator is negative, and then the next one is the denominator is negative, and then maybe one of them, for some reason, they're like negative, numerator and denominator. Maybe the next one's positive, but the next one they show the negative right here in the middle. Well, if this is the case, again, I don't really care what numbers are applied here. I don't even care if there's fractions inside the fractions. All I care about is how many negatives there are. And so we would count. We'd say, well, how many are there? You got 1, 2, 3, 4, 5 negatives. Well, 5 is odd, and so I would know my answer. That's correct. The answer here would have to be a negative. Yeah, and then the good news is once we know that, then we get to ignore all the negatives, and then it's just straight operating, multiplying or simplifying, however you want to do it. To me, another part of the good news here is once you know that, then it's just straight operation. Again, we're ignoring the negatives completely. It's just, all right, 5 times 2 times 8, or simplifying or whatever. Now, we've seen this already. You can simplify with factoring. You can simplify with factoring. I'm going to be using cross simplification. So what this is showing here is if you have values, they can be diagonal from each other in this way or diagonal here, or they can be directly above and below each other. Once you get these values, and it's kind of like factors anyways, then what you get to do is we say you can cross them out like this, or some people like to cross them out like separately, like this. And they'll say, look, Why are they crossing them out like this? It's because they're really ones. They're just crossing them out. Some people say cancel out, but it means the same thing. So, they'll say, that's a phantom one right there, or it's canceled out. Cancel out just means that it's a phantom one, or an A divided by A right there. Anything divided by itself is a one. So if you see matches in the top and bottom and you can divide them by the same thing, then you can at least reduce those values. Now, the reason why I do it, cross simplification happens before any multiplication has occurred. The reason why I think that's important and good is because if you simplify in the beginning, then you're dealing with smaller numbers. Because the last thing you want to do is deal with 1,056, and you're going to divide that by 3. You know what I'm saying? Like, well, you could have just simplified maybe somewhere in the beginning and then had something a little bit more simpler to deal with before. Now, that may be simpler. You may end up with something like...
You can only do that in multiplication.
So this only applies to multiplication. Now, the good news as well is that we never actually do division of fractions in math, at least in this class, because we're going to take all division problems and change them into multiplication anyways.
Yeah, that's right.
So here's this one right here. And again, I showed that example where we had, 5 negatives in there. We shouldn't see that many fractions being multiplied together. We should see something like this. There's 2 fractions. And I'm not going to put it past them to say, look, there's a negative here and then a negative here and here kind of thing. Okay, so just look out for that. You may need to count them. Here, there's only 1, right? Well, there's only 1 negative, so we're gonna put that in. There's 1 negative. 1 is odd. So the answer is a negative. Negative. Boom. Now, just having that much information means that now I get to ignore the negatives. So what we've done is we've taken the negatives and just made it kind of a moot point, right? Like, we don't want to deal with negatives. We hate negatives. Well, most people do. And so we didn't want to deal with that garbage. So we're going to not deal with it. And I'm going to do that by saying I'm going to have an answer here. I'm going to have a fractional answer, or I'm expecting one. But I'm going to put my negative in right now. Just right now. And then from here, I can leave this here. Some students say, you know what, Sal, I'd really like to just not have to look at that garbage. And you can do that because we know that the answer is a negative. That's all we need to know. I'm going to keep it there just kind of for reference if we ever needed to look back and think, well, maybe we made a mistake or maybe we need to look back or something like that, okay? All right, with this now, what I'm going to do is I'm going to focus on the numbers first, right? And then we'll start simplifying with the letters. So the first fraction, so is 8 over 21. And then the second one, again, I don't care that it's negative. It's just 7 over 16, and that's fine. Boom. 7 and 21, right? So I can say 7. Yep. 7 and 21 are both divisible by 7. Okay, so I'm going to cross the 7 divided by 7 is 1. 21 divided by 7 is 3. Boom. Simplified. Now, again, do you want to do 21 times 16? You're welcome to. I just don't want to do it. I'd rather do this, which is just small little bits of division right now instead of lots of long division later. And then we've got the 8 and the 16, right? So the 8 and 16 are both divisible by 8. I can write this. Now, you may do divide by 2 and then divide by 2 and then divide by 2 again. It doesn't matter. And same end of the same answer. 8 divided by 8 is 1. 16 divided by 8 is 2. Boom. Now I'm dealing with much smaller numbers, which I like. I don't like dealing with big numbers. And this is all multiplication. So I'm going to multiply, and this is going to give me a new fraction. So in the numerator, I just have the 1 times 1, which is 1. In the denominator, 3 times 2 is 6. And now that I have this, that's fully simplified. I don't see that this fraction by itself can be simplified. So I'm just going to keep it as is because I can't make it any simpler. And I'm going to write this 1/6 right now into my answer. Boom. Now, are we done? Of course not. We have letters to deal with as well. And so I'm going to do it letter by letter. Does everyone do it that way? No. I don't really care how you do it. But I'm gonna go next to the A's. Okay, so I see I've got this. Whoops. I got this A on the top. Sorry, my handwriting. A on the bottom. So that would just show essentially A divided by a. Anything divided by itself is 1. Now, I don't need to put that 1 in there, but what has happened right there is I'm just going to do some cross simplification in the problem that started with. That's okay. We won't have any a's in the final answer because they all, again, some people say canceled out. I prefer to call it a phantom 1 because it's still there. This one is still there. I can put it over here, and it's still there, but I don't want to look at that garbage. But it's still there, watching, lurking in the shadows. All right, I'll do this alphabetically. So the next letter I see are the b's, right? So I got this b to the power of 4 in the denominator, and then I've got this b in the numerator, so that would be b over b to the power of 4, which is the same as b over b times b times b times b. And again, we see a b divided by b becomes a phantom 1. These 3 b's in the denominator need to stay in the denominator. They're all multiplied together, so I'm going to make it b to the power of 3. Now, not every student needs this, right? And I would never say that it's required of you to be like, if you don't show this, it's garbage, right? I just need to see that you know how to simplify this. And however you do it is up to you. Some students have the exponent rules down, and if you do, that's fine. But again, it's not a requirement here. All right, alphabetically, the next letter would be a T. So that's the T right there. There are no other T's. So since it's in the numerator, I will keep it in the numerator, T. Well, that's nice. How about the Z's? Well, we got a Z to the power of 3 right there. All right, so I got Z to the power of 3 in the numerator, and then I got a regular Z down there in the bottom, the denominator. So I'm going to write that here. I got Z to the power of 3 over just a regular Z. So that's going to be Z times Z times Z divided by Z, and what do you know? Boom. Those Z's become a phantom 1. I now have these 2 Z's in the numerator. They need to stay in the numerator, so that's going to be a Z, but it's 2 of them multiplied together. So we're going to make it to the power of 2. Okay, now this is the way that this is fully simplified, right? We took care of all the numbers. We took care of all the letters or variables, if you want to be technical about it. And this is okay. This is perfect right there. Now, if you meet math nerds from time to time, they're going to be like, you shouldn't show the 1 right there. I don't care. What I need to know is that you know how to simplify, and that's really the main thing I'm looking for. Can you do all this work? And if you can't, I don't care if you show the 1 there or if you don't show it there. Okay, now, well, okay, mixed numbers, right? Mixed numbers. These are still being multiplied, so we're still focusing on multiplication. But try this one out. Try it out, and then we'll go over it. All right. So again, the first thing I would want to do.
Make those improper.
Well, yeah, so I will do that. I will make them improper. But first, even before that, I just want to decide if my answer will be a positive or negative, so I don't have to worry about those negatives ever again. Boom, positive. So, well, why is it positive, though? There's even number of negatives. 2. 2 is even. So, boom, I put my answer. I put negative. It should be positive. Positive. Boom. Now, yeah, I should leave a little space there because I'm going to make my answer a mixed number, even though this is not telling me it should be a mixed number. Now, keep that in mind on an exam or pretty much any assignment. If it does not specifically say make it a mixed number, your answer a mixed number, you don't have to. Okay. Now, if it doesn't tell me, I usually don't because I don't like to do the extra work because it opens me up to make more mistakes, which I tend to do. I tend to make lots of mistakes. So if I don't have to do extra work where I can open myself to more mistakes, then I will not. But we're going to make these into improper fractions, but I'm not worried about negatives any longer. I know my answer is a positive. And, you know, some people, what they'll do is they'll put like a little positive sign up there just so they can see that it is, but it's up to you. Okay, so I'm going to start with 3 3/4. So let's change this into a improper fraction. I know it's going to be in fourths. Why do I know that? Because the denominator is already in fourths, right? Doing this does not change the sizes of the pieces. They're still in fourth size pieces. But what I need is cycle method. Okay, so 3 times 4 first. So 3 times 4, which is 12. And then I'm going to add the 3 numerator plus 3. Boom. So I had 15 fourths. right, let's go to the next fraction. We're going to do 4 1/3. So again, cycle method, but cycle method is only to figure out your numerator. So our denominator, which is a 3, will stay a 3. Okay, well, that's going to be 4 times 3 to start with. 4 times 3 is 12. Then we're going to add the numerator 1 plus 1. It's going to be 13/3. Now, you can put these in parentheses. I like to keep them open, so I'm just going to put the multiplication sign in between. Boom. We have 2 fractions that we can simplify at this point, so we will. And I see the 15 and the 3 are both divisible by 3. So divide by 3, divide by 3. 15 divided by 3 is 5. 3 divided by 3 is 1.
The 4 and 13 don't work.
Correct. The 4 and 13 we cannot simplify, so we won't.
So just finish it up.
Let's do it. Let's multiply. Yep. So I got 5 times 13. I'm gonna stack and multiply this because we probably don't have our 5 multiplication tables memorized to 13.
Can I just say it's 65?
Yeah, 65. That's correct. I'm still gonna show the work just because I'm cool like that. But actually, I'm just a nerd and I like it more than I should. But right, 5 times 3 is gonna be 15. Carry the 1. 5 times 1 is 5, but add the 1 makes that 6. 65, just like we got. In the denominator, we got 4 times 1, which is 4. Now, again, it didn't say that it needed a mixed number, so that would be fine right there. I'm okay with that.
I did it anyway on mine.
Yeah, so I'm going to put an or here because either one will work. But we are going to show the mixed number here. And right now, before I forget, I'm going to put my denominator 4 because, again, I've got fourths here, so I know my answer will also be in fourths. No need to change that. The sizes of the pieces won't change unless we could have simplified it a little bit further, which we can. So if we're going to do this, then we need to do long division. 65 divided by 4. So 4 will go into 6 once. 1 times 4 is 4. Subtract, you got 2 10s left over. We'll drop the 5 there. 4 goes into 25 6 times. 6 times 4 is 24. When I subtract, I get a remainder of 1. So that quotient 16 is going to be the whole value of the mixed number. The remainder is the numerator. And now we have both answers, the mixed number and the improper fraction. Again, I would have stopped there because some people say, well, that's not a lot of work right there. It's enough work for me to make a mistake. And I will. If I am able to make a mistake, I generally do. I try not to, but I do. And the less opportunity I have for making mistakes, the better. So again, either one of these will work. All right, to start us out on this one, we have a fraction in parentheses. We got the negative on the outside. The question I'd like to ask students on this one is how many negatives are there? Now, whichever answer you give, whether it's right or wrong, the truth is the answer is going to be the same. It's going to have the same sign either way, which is good news in my opinion, because I'm going to show right now that the answer is going to be negative. Now that means there has to be an odd number of negatives being multiplied, right? Because we are multiplying. The question is, how many negatives are there? Well, some students would say there's 1 negative. Others would say that there's 3. And again, both are odd, which makes the answer negative. So there's only 1 negative, not 3 on this. So let me rewrite this. I'm going to write the whole thing with the negative, even though I already have my answer written as a negative. So we got the negative, and it's 3/5, but we need 3 of these 3/5. There's 1, 2, we need a third one. 3/5. Now, if the negative was on the inside, of the parentheses, then I would have 3 negatives. That's the difference. In fact, if I had a negative on the outside and then 1 on the inside, then I would have 4 negatives total, which would have actually made the answer positive. Now, that's theoretical. But again, it's important to know how many negatives you're dealing with because it's going to affect the sign of your answer, right? So, knowing that my answer is negative because we only have 1 negative and either one of these makes my answer a negative. Now that we've done that and we know the answer is a negative, let's just get rid of that garbage so we don't get it mixed up again. Okay. Now, here's the other thing. Is inside the parentheses, always just check because they'll do this sometimes, and I think we've seen it happen already, where the inside of the parentheses can be simplified. This one can't. But if it can be simplified, do. Because otherwise you're going to multiply these and then you're going to have something big to simplify instead. the fact that these cannot be simplified means that my final multiplication will also not be simplifiable, which means all I got to do is multiply. So, all right, so showing the work here, I got my numerator, right? I got 3 times 3 times 3. Well, 3 times 3 here is 9er. And then 9 times that last 3 is going to be 27 numerator. I'm showing the work here, but I can put that 27 into my numerator in my answer right now, if you want to. Some students like to wait till they solve it all, but it's up to you. In the denominator, we've got 5 times 5, which is 25. But then I've got to do 25 times 5. So 25 times 5. 5 times 5 is, well, 25. Carry the 2. 5 times 2 is 10, but add the 2 makes it 12. So the 125 denominator. And I'll write that into my final answer. And again, the nice thing about this is I already had the negative planted in my answer, so I didn't have to worry about it, right? In the past, and you could even check my YouTube channel for this, but in the past what I would do is I would wait till the end to put the negative in there, and then I forget to put it in there. And so, you know, students, especially junior high students, they like to make fun of old guys that make mistakes, but, you know, I've become numb to it anyways. But I would recommend doing that in the beginning, because if you wait till the end, you'll make mistakes like I do, and we don't want that. All right, multiplying fractions with whole numbers. Now, this is abstract, so it has letters. But the A, it could represent any number. For example, if you had like a 5, right? 5 could just be written as 5 over 1. Or maybe it was even a negative, like a -7, right? If you need, because we're operating with fractions, and if we're operating with fractions, what you don't want usually is just a regular number like this. What you want to see it as a fraction, right? So you'd say, you could even write it as -7 over 1 like this. Or if you wanted to show that negative in the front, you could, like this. It doesn't matter as long as you know that the negative is there, if there is a negative there, right? But the good news is, like we've already done, is once we see that we have a negative, or however many negatives there are, then we can determine if the answer is a positive or a negative. And then we get to ignore all the negatives, and that's good. Now, the last thing, this part right here, this is how we kind of start with. So what they'll do is they'll say like 5 times -3/5 or 4/8, I don't know. So yeah, 5 times that, and you'll want to write your whole numbers as fractions like this. But in the end, if you end up with something like this, where it's like -7 over 1, and again, this is more of a math nerd thing, but if you go to Math Nerd and write an answer like this, they can freak out about that kind of stuff. They say, it's not fully simplified because dividing by 1 is just itself. Just do yourself a favor and write your answers like this. Again, I don't really care because I think it's right either way, but math nerds get really picky about that kind of stuff, so just be careful. With that, then, try this one out. Try this one, then we'll go over it. All right, so we see on this one, we see a negative being multiplied. Again, I'm expecting a mixed number out here, but since we only have one negative out here in the front, I will expect the answer also to be a negative answer. Well, now that we have that, we don't have to worry about any negatives anymore. And in addition to that, for the work now that we're starting to work, I'm going to show this as 4 over 1, because I would like to see a fraction multiplied with other fractions. Now again, I'm going to rewrite it for the work down below, but I don't care about the negative because I know my answer is a negative. And then I'll use some cycle method here with 3 1/2. Well, that denominator is not going to change. But 3 times 2 is 6, and then add the 1 numerator is going to make that a 7 over 2. Still multiplied together, and then we can simplify the 4 and 2. They're both divisible by 2. Divided by 2, 4 divided by 2 is 2. 2 divided by 2 is 1. And now we're ready for the final multiplication, which is going to give me the mixed number. And so we got 2 times 7, which is 14 in the numerator. In the denominator, 1 times 1 is 1. And of course, the answer would have been a negative. Oh, so I guess I jumped ahead of myself there. It would show as negative 14 over 1, but again, to make this simplified, we're just going to show it as negative 14. I'm going to circle that one. All right, here's a little vocabulary which you may have gone over in your previous class. Let's say you didn't, because that's why we're reviewing. reciprocal, which is kind of a weird word. Reciprocal. It's a weird word. It's not something you'd probably use in your everyday conversations, but academics do it because it sounds nerdy, right? Well, reciprocal is something that we do when we divide with fractions, because what it does is it takes away the division and changes it into multiplication. All it does is flip the fraction. So if you want to be nerdy about it, you could say reciprocal, or if you wanted to talk in layman's terms, flips the fraction, okay? So if you start with a over b, and again, this is abstract, so it could have been numbers. Let's use some numbers. Let's say it was, well, let's even say 8 11ths. Maybe 7 11ths would have been better. But let's even say it's negative right here. And let's say that we reciprocate that. Reciprocation has nothing to do with the sign. All it has to do is with the number. So this fraction will still be negative, but what happens is we flip the fraction, meaning the denominator, which was 11, is now the numerator. The numerator, which was 8, is now the denominator, 8. And this has been flipped or reciprocated. But again, the main use for reciprocation in this context is to make a division problem a multiplication problem. So, like I said before, we don't ever actually multiply with fraction. See what I did right there? We don't ever divide with fractions. What we do is we change the division into multiplication, and then we just do everything that we just barely did in those last few problems. So we don't actually divide fractions. We're just going to change the division into multiplication with reciprocation. But we're only going to reciprocate one of the fractions. And I think I remember seeing this on that last exam we took. I saw someone that reciprocated that first fraction. Well, it's been a while, so don't feel bad about that. Plus, we should be okay with making mistakes. But the first fraction will stay the same. Notice we got a over b. Well, it stays a over b. The first fraction stays the same, but we're going to change this division into multiplication by, see how it was c over d, it reciprocates into d over c. Now, once you get it into this format, into multiplication, then you do your simplification. Another common error that I've seen before is where students like to simplify with the division right here. And they actually do it right because they know that it's going to reciprocate. But I would not do any simplification or cross simplification here. I would wait until you get to this point and then do your simplification. That's just a warning. Again, some people still do it right. I just don't want to see anyone make mistakes, because that happens more often than people do the right thing there. So answers should always be in simplifying form. And again, you only need to write the answer as a mixed number if it says you must do so. So we're going to do it in both if it needs it. If we end up with an answer that's an improper fraction, we will write the answer also as a mixed number for the lesson. Well, the last thing I'll say about this slide is the negative thing, right? Because this is not showing any negatives, because we don't need to worry about the negatives. We're going to do that before we do any reciprocation. Just look at any negatives in this problem, even though it's division, because it's same for multiplication as division. If I have an even number of negatives, I know the answer will be a positive. If there's an odd number of negatives, I know the answer will be a negative. And once we have that, then we don't have to worry about negatives anymore. It's all just straight operation. So we haven't seen any letters yet. I don't think we see any in this particular assignment. That's okay. So, again, the first thing I would do, because I'm going to write my answer, I'm expecting it to be a fraction. Maybe it's an improper fraction. Maybe we'll change it into a mixed number. I don't know. But the first thing I want is to determine the sign of my answer to start with. 1 negative, 2 negatives. Well, 2 is even. Since there's an even number of negatives, I know my answer is a positive. Now, again, some students like to write a little positive sign right there. Definitely don't do that in the assignment, but while you're doing your work, if you want to show that, that's fine. Okay. Now that I have that, I don't care about the negatives that are in the original problem. But what I'm going to do is I'm going to take that 12/25. Again, the first fraction will never reciprocate from division to multiplication, but I will change this to multiplication right now. So my division is going to change to multiplication by reciprocating that second fraction. It's 12/25 then times, now it's 5/8. We reciprocated, and now I don't have to worry about any division. In fact, most students hate division. So hopefully this helps us. It does us a favor, And with this, now we can look into simplification. So I would probably notice the 12 and 8 first. Well, maybe even the 5s, right? The 5s are pretty Easy work with it. But I'm going to start with the 12 and 8. These are both divisible by 4. Now, if you said 2, you just have to divide it again. That's okay. 12 divided by 4 is 3. 8 divided by 4 is 2. So there's the 12 and 8, but the 5 and 25, these are both divisible by 5. So 25 divided by 5, we'll start there, is 5. 5 divided by 5 is 1. So now that we have that, we are ready to do the multiplication. Now again, the fraction here is going to be positive. And I'm multiplying the simplified numbers. And I don't see anything else that can simplify. So 3 times 1 in the numerator is 3. 5 times 2 in the denominator is 10. So my final answer, already got the positive sign there, but 3/10. Of course, that can't be changed into a mixed number because it's a proper fraction. Well, you could have circled either one, by the way, but whatever. All right, let's go and divide these, but take a minute, try this one out. Try this one out, then we'll go over it. Okay. Now, I don't see any negatives on this one. Again, if there were, we would count them and then figure out if our answer is positive or negative. I don't see any. So once again, that first fraction, I don't care what it is. This one, I'd say it's kind of ugly, but I don't care. I can just drop it as is. It's that second one, since we got a division problem, we're going to change this into multiplication, and then I will flip this second one. So my fraction down here now, the old numerator, 25k, will be the denominator. The old denominator, 4m, will now be the numerator. And that now has changed into a multiplication problem, which is what we do want. Now, however you do this is completely up to you, of course. Some students actually like to simplify at this point, and that if you do, that's completely up to you. In fact, you know what I'll do is I'll show both ways. So I'll need a little bit more space here. But I'm going to copy and paste this over here, and I'll show you how some students do it without breaking it up into separate parts. Whether you want to do that is completely up to you, though, right? So now that we have that, let's look at here. So let's just look at the numbers, right? Because we're going to break this up into smaller, more manageable parts. So we got 110 over 10, and we're going to multiply this by 4 over 25. Now, some students may look at the 0 in the ones place value and the 5 in the ones place value and simplify there. I like to say, look at those zeros, boom. I make those into a phantom 1. And what that does is it pretty much gets rid of them. So now, instead of showing this as 110 over 10, I now have 11 over 1. So that's what that means by crossing those out. The zeros, which I think we saw, I think that was in module 1 or 2. That we saw. So it has been a while. Now that by itself, just taking care of those zeros, because I divided them both by 10, so I'll show the work. What the heck? So it used to be 110 over 10. What you can do is take 110 and divide it by 10, and 10 and divide it by 10, because they have zeros on the far right end of these. Well, 110 divided by 10 would be 11. 10 divided by 10 is 1. And now all the fractions are simplified. So whether you divided with the 25 or the 10s, doesn't really matter. All right, so let's go ahead and simplify this. Or it's already simplified. Let's go and multiply this. That's what I meant. And again, remember, in the beginning, there weren't any negatives, so I didn't have to worry about any of that garbage. So in my fractional answer, I got 11 times 4 in the numerator, which is 44. And the denominator, 1 times 25, is 25. So in my answer, which I'm going to go ahead and put back up here at the top, I have a 44 in the numerator and a 25 in the denominator. Bam. Okay. Now, I'll do the k's next. Let's go to the k's. So I've got a k to the power of 2 in the denominator right here. And then I've got a k in the denominator. So it's got k over k, k squared over k, which is k times k over k. And one of the k's in the numerator and denominator becomes a phantom 1. And so I'm just left with that k in the numerator, so I'm going to keep it in the numerator. K. Bam. Excuse me. Next up, we've got the m's. I've got this m in the denominator and this m in the numerator. That's m divided by m, which becomes a phantom 1. We just don't need to show that 1 in there. So fully simplified, this is what we get. And with the letter in this answer, I wouldn't expect this to show with a mixed number at all. So if you put this into a mixed number, it looks like you would have gotten 1 and 19/25. K, but again, the K in there is where it throws a wrench in things in terms of format. So I wouldn't even worry about it. I'd just keep it like this. All right, now with that, let's go back to, because I said, well, you could do this kind of with the original fractions, right? So let's take a look at these ones up here in the top right. So what I'll see sometimes is students, they'll say, look at the, again, like the zeros right here, they'll make that a phantom 1. Or right here with the K squared, they'll show K times K instead, and then they'll get rid of those Ks. And then the M's will kind of go like this. And then they'll do like a 4. Or I'm sorry, we already did the simplification there. So at that point, they're just showing something like this. And by the way, this is enough to say that you've done the work. Like, I'm showing the work. Okay. Yeah, that looks like enough work for me. And then they'll say 11 times 4 is 44. We got the K on the top as well. And then 1 times 25 in the denominator, 25. All that's good. But it's the same answer, right? 44K over 25, 44K over 25. Same thing. I got 3 fractions all divided by each other. Here's what we're going to do. Try this one out. I know we haven't done one like this yet today. We did some like this. Again, I think it was module 2. Maybe it was module 3. Just try it out. See how you do. And then we'll go over it together. So if you haven't realized yet, my shtick is do smaller problems. Even though this problem has 3 terms, for example, 3 parts being divided, 3 fractions being divided, I'm not going to divide all 3 fractions at the same time, as much as fun as it sounds. What I'm going to do is focus on 2 at a time, and we have to do this from left to right. That's an order of operations thing. Okay, so we're going to do the division first on the left, which is negative 3/7 divided by negative 7/4. In fact, before we get to that, which I should have done already, what I would like to do is just show if my answer is going to be positive or negative. And we're expecting a fractional answer. Maybe it'll be a mixed number. I don't know. But right here, I see 1, 2, 3 negatives. 3 is odd, which means my answer will also be a negative. So that by itself is great, in my opinion, because then I don't have to worry about negative 3/7 or negative 7/4. It's just 3/7 divided by 7/4. Okay. But notice, I am ignoring, right now, I'm ignoring the divide by negative 9/4. We'll get to that. I'm not worried about that right now. Now, the truth is, and I'm gonna get a little bit ahead of myself here, is you could say, I'm gonna change this to division by reciprocating this fraction. And you could change this to multiplication by reciprocating this one as well right now. And then you could do cross simplification throughout. Like I said, I like to simplify, I like to look at smaller parts of the problem as I go, which I think hopefully it helps to kind of keep things a little bit more organized. But students do it differently, and that's fine too. Okay, so I've got 3/7 divided by 7/4. Again, I don't care about negatives anymore. But the 3/7 will stay the same. The first fraction always stays the same. But I'm going to change this division into multiplication by reciprocating that second fraction. So now it's 4/7. Okay, now as far as I can tell, that is not simplifiable. I don't see anything that can simplify there. So that means that I'm also ready to do some multiplication. So I'm expecting a fraction. Again, I don't care about negatives. But 3 times 4 in the numerator is 12. 7 times 7 in the denominator is 49er. 12/49. Now I'm going to rewrite the whole problem, but with a little bit of simplification there, right? So I got 12/49, but now we're going to divide this. I'm going to show the negative just because I'm dropping this down, but I really don't care about that negative anymore, right? So I'm just going to show it as 12/49 divided by 9/4. And this is division again. So again, I was excuse me, I was ignoring this before. Now I need it because I simplified the first 2. And so we need a little bit more space. And well, let's go ahead and change this division into multiplication. That means the first fraction will not change. It'll still be 12/49, but the second one will reciprocate. So it's going to flip into 4/9. Okay, 49 is kind of a weird number. 7 times 7, of course, which is not divisible by 4 or 12 or 2 or 3 or 6. But what I can do is I can take the 12 and divide it by 3 because the 9 is also divisible by 3. 12 divided by 3 is 4. 9 divided by 3 is 3. That's as much multiplication that I can see. So now I'm ready to do the multiplication. So in the numerator, I've got 4 times 4, which is 16. In the denominator, 49 times 3. I'm going to have to stack and multiply that. So 9 times 3 is 27. Carry the 2. 3 times 4 is 12, but add the 2 makes that 14. So 147. Well, we have the negative already attached to the answer, so I'm going to write this fraction into my answer. Negative 16 over 147. Done. All right, last time we saw this slide a little different, but division with 0, right? So 0 divided by anything is 0. Anything divided by 0 is undefined. Now, I think I remember seeing this either on the assignment or an exam, where they were like, show why this is, or prove why this is true. Because look, if you did like, let's just put in some values here, like 0 divided by 5, right? Which is 0. Now you could show this with long division, which I'm okay with. So how many 5s? I'm trying to make a better 5. How many 5s are in 0? That's what this is asking right here. There is no 5s in 0, right? How many 5s are in nothing? Well, there's none of them. You can't have any of them. The other way to do this is to show that you use a fact family where you take the dividend and the quotient and show that you can take those, which would be 5 times 0. 5 groups of nothing is still nothing, like this. Now the next one, anything divided by 0, so let's use a different number. Let's do 9. 9 divided by 0. This one's undefined. In the assignment, I think you'll put in D and E, which is the same. It's essentially saying the same thing as undefined, which is would show 9 divided by 0. Now this is asking how much of nothing is in 9. Well, there's an infinite amount of nothing in 9, but again, we like to just show it as D and E, or undefined value. Now that's using division, but again, if you were to change this into multiplication with the fact family, you'd have something, 0 times something, which again, is why it's D and E, is going to be 9. And I'd put a question mark over that because I can't think of anything I can multiply 0 by to get 9. Not that's real anyways. So that's why that's undefined. Okay, so this one, 0 divided by 5, you got the hot air balloon and the carriage. Okay, that holds, right? Because the hot air balloon, you got 0 divided by 5. That's okay, it's 0. But yeah, if you flip this upside down where the 0, again, the 0 is the hot air balloon part. It's upside down, boom, you're going to crash. And I can't imagine that being very fun. Of course, I can't imagine the hot air balloon being very fun. So, but I'm afraid of heights. So there we go. Boom. Now the hot air balloon thing, right? If you're going to keep the hot air balloon thing going, then you write the fraction. Remember, it's this one would be negative 3/5 over 0. The second one there would be 0 divided by negative 9 over 11s. Now again, it doesn't matter how you remember it, or if you want to show the long division or the change it into multiplication, it's up to you. The 0 as the second number is always, or the second value, which is the dividend, is always going to be D and E. If it's the first number or the divisor, it's 0. Or again, you can use the hot air balloon examples for both these. This is the way it's going to go. Okay, now I would say it's better to just have this memorized one way or the other. However you memorize it, whether it's the balloon thing or the long division or the multiplication thing, than to just guess, because some people guessed on that last exam and it was opposite. Some students are like, you know what, I'll take my half credit and I'll put 0 on both. And it's like, okay, well, you get a half credit. But again, if you can just memorize that, then I think it's good. There's our objectives, our objective. I can multiply and divide with negative and positive fractions. Yes, we've already done positives. That was, I think, module 2. But now we are looking at with negatives. So again, the first thing you do, just determine if your answer is negative or positive, write that in, and then do whichever operation, multiplication or division. Now, again, I just can't stress this enough. These rules do not apply to addition and subtraction, which I think we do next time. So just be aware, when we do addition and subtraction, it's kind of like its own separate thing. The idea is still the same. You want to determine if your answer is positive or negative, and then your operation comes. But you're not counting how many negatives there are.